Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide a bunch of examples of how to find the nth term of a geometric sequence. So we're going to look at the following examples here. These sequences 1, 5, 25, and we're going to look for the 10th term, 36, 24, 16. We're going to look for the 12th term, 3, 12, 48, and we're going to look for the 8th term. All right. Now, there's a couple ways to do this. Method number one is what I call the brute force method. Brute force method is just keep going with the sequence. You'll notice that from here to here is multiplied by 5, from here to here is multiplied by 5. We could just keep going until we get to the 10th one. We could do the same thing here and here. But what I'm going to do instead is try to write a formula that will give me the nth term, and then I'll just put a value of 10 in. So remember that geometric sequences look like this, where the a sub n is equal to some a1 value times r to the n minus 1. The a1 is pretty easy to pick off. Here it's a 1. The r value you get by, what did we do from here to here? That's times 5. From here to here, that's times 5. So in this case, r is equal to 5. So I'm going to rewrite this. A sub n equals a1, which is 1, times 5 to the n minus 1. Now, here it's pretty obvious, how to get this, but notice that the 5, if I take 5 divided by 1, I get 5, or if I take 25 divided by 5, I get 5 again. You can always get this value by taking any one of these and dividing by the previous one. Now what I'm going to do is just put in n equals 10, so a10 is going to equal 1 times 5 to the 10 minus 1, which is to the 9th. And I'm going to go ahead and calculate a value here, and we get a pretty big number. I end up with, let's see, 953,125. All right, that's a happy looking number. Let's take a look at this thing. All right, so I'm noticing that it's geometric. There's likely a multiplication that's getting me from here to here, here to here, and so forth. And I can get the r value very easily by taking this guy, dividing by this guy. Or we can take this one, divide by this one, it doesn't matter. So the r value is going to equal 24 over 36. And let's see, 12 goes into there twice, and there 3 times. So in this example, a sub n can be written as a1, the first value, times r to the n minus 1. And again, always check to make sure you're setting these up right. Starting at n equals 1, if you put a 1 here, 2/3 to the 0 is just 1 times 36, and that matches. All right, so now we want the 12th value. So a12 is going to be 36 to the 2/3 to the 11th power. By time we do 12 minus 1. And if you give me a moment here, I'm just going to run a value here. And if you take a calculator and just wash that out, what we're going to end up with is 0.416 is good enough for our 12th term. All right, let's take a look at this guy here. Again, as I kind of look at this, going from here to here, kind of looks like that was multiplied by 4. From here to here, multiplied by 4, and so forth. So our a sub n here is going to equal an a1 times 4 to the n minus 1. And again, if you're not seeing where we're getting this, you can always get the r value by taking any of these. Take like this, divide by the previous one. Or you can take this one, divide by the previous one, just like we did up here when we took 24 over 36. Or here, if you take 5, divide by 1 to get the r value. Now I'm going to go ahead and just put in the 8. So a sub 8 is going to equal 3 times 4 to the 8 minus 1. If you don't mind, I'll just put 7, and I'm just going to run a value here. All right, I get 49,152. So I got a couple more examples I want to look at here, folks. So if you don't mind, I'm going to pause this and clean this up and write those other examples down. All right, I'm back. That was quick, huh? So, two more examples to look at of geometric series. Now, again, it's very important to realize how to recognize a geometric series. You know, when I go from here to here, that's a multiplication by 3. From here to here, that's a multiplication by 3, right? That's a multiplication change, not an addition change. This point here, if you're watching this video, I imagine you're having panic attacks because of these. Like, oh my goodness, what are we going to do about those? And the answer is we're going to work this exactly like we did the previous ones. There is no difference. So we're going to start by saying, all right, our a sub n is equal to the a1, which is minus 4, times some sort of r to the n minus 1. Now the r value you get by taking this, dividing by the previous one. That's negative 3. Get the same thing if you take negative 36, divide by 12, and so forth. All right, so there's my formula there for the a sub n. And again, this formula would be true starting at n equals 1. I keep saying that because in a lot of books, you know, formulas like this very often start at n equals 0. But the current college algebra textbook that I'm using likes to start these all at n equals 1. All right, a6. How are we going to get that? We're going to take negative 4 times negative 3 to the 6 minus 1, which is 5. All right, and what I'm going to do here is just do the sign in my head here. So a negative number to the 5th power is negative, times another negative is positive. So this result is going to be positive, and then I'm just going to take 3 to the 5th power, multiply it by 4, and out comes positive 972. All right. Sequences and series, they are exciting. So we're going to take this one right here. Let's see, taking note here, how did I get from here to here? Well, again, that's, you know, ignoring the minus sign for a moment, that's a division by 3. And then look at this guy, 3 to 9, another division by 3, and so forth. We're going to work this exactly the same way. We're going to say that a sub n is equal to our first value, negative 1, times some sort of r value to the n minus 1. The r value we can get by taking any one of these. This time I'll take this guy. Divide it by this guy. If you take, I'll go ahead and write this out, negative 1/9, and divide that by 1/3, you get negative 1/3. All right, and you'll notice if you take 1/3 and divide by negative 1, you get negative 1/3. All right, what do we want to do now? We want to calculate the 8th value of this sequence. So a8 is going to equal negative 1 times negative 1/3 to the 8 minus 1, which is 7. Let's talk plus and minus signs first. Negative number to an odd power is negative, times another negative is positive. And let's see, do I want to do decimal or fraction? Doesn't really matter. Let's do fraction here. So this is going to be 1 over 2187, because 1 to the 7th is 1 and 3 to the 7th power is 2187. Or, you know, if you wanted to write that in fraction form, or I'm sorry, what I meant by that was decimal form. Whoops. .000457 is good enough. So this purpose of this video was to help demonstrate how to find the nth term of a geometric sequence. I hope that this does that adequately for you. Have a great day.